Hello everybody. Thank you for selecting this video. I hope you will enjoy the subject that I have presented to you today. It's again the subject of converting a global into a JSON object and writing it to a file. The difference to the previous version is that this time the whole code is just written in embeddedPython without any line of object script, which is quite a challenge in one sense, and so I named it GlobalToJson pure, since the only thing that is really around it is the iris class. That is a normal class in iris, but all the code inside the class is just in Python. And you will see what happens. But first, let's see what is all around. Just to remind you what we are doing, this is the structure of a global, and what I use is the same strategy as we have used for the efficient conversion. So only the nodes containing data are really put into the JSON object, not these empty structural nodes that are in between. The global I use for this example and also embedded into the package is still the same as before. We have a top level, we have typical record levels embedded in list blocks. We have also manually added a few JSON objects, and not just a one-to level, but also manually added levels for more structures with strings contents, with numeric contents. So it's the same as before. So this is the running version of all these examples. Yes, and this is the generated structure, the generated JSON file. You see a few differences here, like the global name is now real part of the outer container. Then when you have the list of nodes, and here you have just the subscripts. The top level has of course no subscript, but all the others you have the subscript in the form as a JSON array. And this is very similar to what you use inside embeddedPython. These arrays are really used more or less the same, almost no conversion, just to access the globals. Another interesting point is that the values here are, this is a string, but this strange structure is the dump of a list build object. And as embeddedPython has no relation to list build objects, it just takes it as a binary string of characters, and that's it. This is not very comfortable and it's not very easy to read, but it's exactly the same format that you can use directly from embeddedPython to write into a global without need of any transformation. You have no transformation before, you have a binary string, and when you write it in, you write exactly the same binary string in. And that's it. It's just in between, not optical, so attractive, and definitely not possible to edit with a lot of chance to destroy something. Now let's take a look into the class that we run. It's a normal class in Iris, special parameter language Python. So it's not necessary for the various methods to indicate the language again. So we have two class methods. This one, do, is the first one. And the first thing you see here is the subroutine to simulate the $data. $data should tell us if a global exists, if it contains data, and if it has subscripts. First we check for the subscripts, and here we have we use the order function. If there is some content, okay, then the global has subscripts, and that's fine. So the first one of the 10 of the 11 is there. If there is no subscript, then it may just have data on the top level. To go further on, we have I access the global to get the value, and differently to the get that we know from Iris, from ObjectScript, this get just throws an exception key error if no value is existing. That's a little bit strange, but anyhow, it works. You have a try except structure. If there is no value, there is just no data at the top node. So if we had subscripts, then the value is 10. If we had just data at the top level, the value is 1. If there is nothing at all, we return 0. And if both exist, then return the 11 that we had initially there. And as we access, we get, of course, already the value, and if available, we pass it along. This one is just built and composed for the top level, as I don't need anything else. If you have to pass subscripts, you may pass it as a parameter to this function, as an additional parameter to this function. The next subroutine is the one that builds the JSON object that contains the subscript and the value. This is this node subroutine. You build the JSON object, which is standard, and then to write it out to the file that is already initialized, and well, you separated the individual entries by comma, and this is the return value. The first has, of course, no comma, and all others are separated by comma. Nothing dramatic, pretty much almost with no change, the same that we had in the previous example. And now we continue to our main routine. The first we do when we enter to replace the leading caret if available, since for access from embeddedPython with the global ref function, you know that you are using a global and nothing else. So the caret is removed. It works with both, and removing it makes us sure that the global name is really just the name and not the caret, which is important when you reload it and have no clear idea what you have around there, so you make it sure. The next step is to run $data over the top node to see if the global exists at all. Well, and then you step in. You still have to define a file name if not provided. It's just routine, and we init the file with the global name and then start the array for the individual nodes that we generate with the subroutine shown above. We handle the top node as a first, and then we use the query function of the global reference to load all subscripts, including the data, into a Python structure, and hopefully you have enough memory to do this, since I didn't find any error message if this doesn't fit. The next step is to run in a for loop over the loaded structure, and as I've told you, we also get nodes that don't in practice not exist because they don't have data. You get this node and then the data are set to none. We skip it. In other case, we just write it out with the node subroutine and get the next. And once we are done, we write the termination close of the JSON object and close the file. Reloading the global from our GlobalToJson file, or whatever the file name was, is rather simple. You go into the file and read it line by line, checking for the termination. Then stripping down the top node to get the global name, and then you run it line by line and get your JSON object that you load. You get the substructure, the subscript structure, and the value, and you just write out. Once again, a special handling for a top level node that has no subscript, therefore subscript none. Otherwise, you should write with the global reference and the related subscript the value out. And as you see there is not a little bit of object script and also no sign of handling list build elements, since you have stored it as a binary string in the beginning. You just use it here and write it in again as a binary string, and in fact you have no idea what you're really writing. You're getting in the value, you write it, and you just don't care, and that fits. Yes, it's I really would recommend to you, if you intend to work with globals, take a look at this. There are some strange situations. It's version 1. It would be a surprise if there were no bugs in, if there were no problems in, but that's the start. And in fact, with a modern application, how often do you really need to access the global? Is it something you have to do very often? And if it doesn't work, you still have the option to call object script routine. No problem. You have seen this in the previous example. Okay, this was the video. I hope you enjoyed it. I hope it was interesting to you, and I hope you will see me again with my next video on this channel. Goodbye.